Good afternoon. Today we'll see one more problem. We'll be solving this problem using the branch and bound method. So max z is equal to 3x1 plus 5x2 subjected to 2x1 plus 4x2 is less than or equal to 25, x1 is less than or equal to 8, 2x2 is less than or equal to 10, the x1 and x2 is greater than or equal to 0 and integers. So this we have to solve using the branch and bound method. So as we used to do, so I'll divide this into 3 partitions. So now first I'll solve the first constraint 2x1, this is this 2x1 plus 4x2 is equal to 25. Okay, now let's consider x1 is equal to 0. If x1 is equal to 0, this becomes 4x2 equal to 25 and which in turn x2 becomes 25 by 4. Okay, so this becomes 6.25. So one of the point is x is 0, x1 is 0, x2 is 6.25. Now, let's consider x2 is 0. So, let's consider x2 equal to 0. Then what is x1? 2x1 equal to 25. Therefore, x1 is equal to 25 by 2 which you will get 12.5. So, now x1 is 12.5 comma x2 is 0. This is one more point. This is just nothing but x1. This becomes x1 is equal to 8 and this becomes x2 is equal to 10 by 2. So you will get 5. Okay. Let us draw this using the graphical method. So here this is 0, 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. This is x2 axis, this is x1 axis. Now first point is x1 is 0, x2 is 6 point. This is 7, so 6.25 is somewhere here. 12.5, x1 is 12.5 somewhere here and 0. So we'll join this. Okay, this line represents actually 2x1 plus 4x2 is less than or equal to 25. So your solution will be less than, so within this region. Now we'll include other constraint also. x1 is equal to 8. x1 is equal to 8 is this one. So we'll be drawing a parallel line to this x2 axis. So this is x1 is less than or equal to 8. So your solution will be less than within this region. x2 is equal to 5. x2 is here and equal to 5 indicates parallel line to the x1 axis. So this is 4. So this will be 5. So your value will be within this region. Okay. This is x2 is less than or equal to 5. Now what is the feasible region? See, it should be within this, it should be within this, it should be within this. So you will get here feasible region will be only this will be the feasible region. This will be the feasible region. Now find out the values. Here anyhow it is 0, 0 and this point x will be 8, y will be 0 and here this will be 5, x is 0, y is 5. Okay, so what are all the points we will get here? 0, 5. This is anyhow 0, 0. This is 8, 0. Find out what is z value. Next we have to find out what is the value of this intersection, what is the value of this intersection, because this is also our visible region. So to find out the value for this, how will you find out? This point you got from the intersection of the values from the two equation. What is the two equation? This equation as well as this equation. What is this equation? X2 equal to 5. So x2 equal to 5, that you have to substitute in this equation, intersection of the second one. So 2x1 plus 4x2 equal to 25. So 2x1 plus 20 equal to 25. 2x1 is equal to 5. x1 is equal to 5 by 2. This gives you 2.5. So 2.5 comma 5. This is your one more point. So 2.5, this represents 2.5 comma 5. Find out the value in this intersection. How did you get to this intersection? This curve or this, the value from this equation as well as one more equation is x1 is equal to 8. So solve this. x1 is equal to x1 is equal to 8 and this value is 2x1 plus 4x2 equal to 25. So here 16 plus 4x2 equal to 25. 4x2 equal to 25 minus 16. 4x2 is equal to, you will get here 9. x2 equal to 9 by 4. Okay, you will get here 9 by 4 equal to 2.25. So what is the one more point here? This point is 8, 2.25. Now find out all the z value which gives us maximum optimal solution. So this point is 2.5 comma 5. What is the z value? This intersection point is 8 comma 2.25. What is the z value? So if you calculate this one for 0 comma 5, your z value is 25. 8 comma 0, z value is 24. Just substitute this in this equation x1 and x2. 2.5 comma 5, you will get 13.5, and 8 comma 8.25, you will get 35.25. Among this, which is the maximum value? Maximum value is this one. So we will be considering this for the next iterations. So I will be writing here z is equal to 35.25 and its corresponding x1 value is 8, x2 value is 2.25. Now these are not integers, so we'll be again branching this x2 as this 2.25 lies between 2 and 3. So x2 is less than or equal to 2, x2 is greater than or equal to 3. Now include these two constraints in this equation and again you solve using the graphical method. This constraints in this problem and consider this condition in this one. All other are the same, and here 2x2 is less than or equal to 10, so x2 will be less than or equal to 5. Okay, now join or use the graphical method. So here this will be x1 axis, this is x2 axis, this is x2 axis, This is x1 axis. So 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. So first point is 0, 6.25. 0, 6.25. 12.5, 0. So join this. Okay, 6.25, 12.25. So join this. Now consider this. x1 is equal to 8, x2 equal to 5, x2 equal to 2. Here also x1 is equal to 8, x2 equal to 5, x2 equal to 3. Draw the x1 axis. x1 is equal to 8, x1 is equal to 8. So your point is here. So like this. This is x1 is less than or equal to 8. x2 equal to 5. x2 is this one. So x2 equal to 5. So x2 will be less than or equal to 5. x2 again it is less than or equal to 2. x2 is less than or equal to 2. Okay, now decide which is the feasible region. See, x2 is less than or equal to 5. So it should be within this, and it should be within this. It should be within this. Now since it is x2 should be less than or equal to 5, it should be within this. So what is the region you will get? Only you will get this region as a feasible region. Only this region as a feasible region. So what is the value here? Here the point is x1 is 0 and x2 is 2. And here it will be x1 is 8, x2 is 2. And here this point will be x1 is 0, x2 is 0. So now find out the values, corresponding values here. x1 is equal to 8. x1 is equal to 8. So x1 is less than or equal to 8. x2 is this axis equal to 5. So if 5 is somewhere here, x2 is less than or equal to 5. So your feasible region is within this. Within this. x2 is greater than equal to 3. 3 is here. So x2 should be greater than or equal to 3. So again the symbol will be like this. What is the feasible region now? Feasible region is only here, here, here. These are our feasible region. What are all the points? So the points are, in this case it is x1 is 0, x2 is 5. And in this case it is x1 is 0, x2 is 3. And in this case you have to find out, and in this case also you have to find out whenever there is an intersection. And here to find out the intersecting point, what you have to do? Solve this equation. x2 is equal to 5. x2 equal to 5, you substitute in this equation number 1. So 2x1 plus 4x2 is equal to 25. You just substitute there. You will get, if I substitute here, I'll solve here. x2 equal to 5. x2 equal to 5. And this I have to substitute here. 2x1 plus equal to 25. 2x1 equal to 5. x1 is equal to 2.5. So this point will be x1 is 2.5 comma x2 is equal to 5. Now to find out the point here, how will you do? intersecting. What is this line represents? This line represents x2 is equal to 3. So x2 is equal to 3. And what is this line? This line represents this. So 2x1 plus 12 equal to 25. 2x1 equal to 13. x1 is equal to 6.5. So you will get here, this point will be 6.5, 3. Now write down all the z values. So z values are, for 0, 2, z value will be, for 0, 2, z value will be 10. 8, 2, z value will be equal to 20, 34. For this 8, 0, z value will be equal to 24. And here for 0, 5, 2.5, 5, 0, 3, 6.5, 3. So you will get 0, 5 z value equal to 25 and 2.5, 5 z value will be equal to 32.5. 0, it's it 0, 3. So 0, 6.5, 3 z value will be equal to 34.5. 0, 3. Substitute 0 here. 0. 5 3s are 15. Now, which one to consider? Which gives us maximum optimal solution? In this case, maximum solution we will get from this. So, if I consider this, our value will be z is equal to 34 with the value of x1 is equal to 8, x2 is equal to 2. If I consider this constraint, our value will be equal to z is equal to 34.5, more than this. Okay, so I can preferably go from this side, and x1 is equal to 6.5, x2 is equal to 3. Okay, x2 is equal to 3. So what it indicates? Here, even though it is integer, if I travel in this path, might be I may get more maximum optimal solution for this z. So I will again consider this equation. So in this equation, the x1 is in decimal. So consider this x1, and here x1, value lies between 6 and 7. X value is less than or equal to 6. X value is greater than or equal to 7. So again, consider this x1, x2 is greater than or equal to 3. Along with this, add one equation is this one. One more equation will be this. Now, include this equation here and this equation here along with this constant x2 is greater than or equal to 3 here as well as here. You have to remove this x2 is less than or equal to 2 because we are traveling in this path now. Now start again. For this 0.625, x1 is 0 and it's 6.25 and 12.5 to 0. 6.25, 12.0. So join this. And here also join this. Now start from here. X1 is equal to 8. X1 is this one. X1 is equal to 8. X2 is equal to 5. So X2 is less than or equal to 5. x2 is greater than or equal to 3. x2 is greater than or equal to 5. Again our direction goes like this. Okay. Again x1 is less than or equal to 6. x1 is less than or equal to 6. Again one more constraint, it should be less than or equal to 6. What is our feasible region now? Feasible region is our value resides within this. These are our feasible region. So what is the value here? The x1 is 0, x2 is 4. And here what is the value here? x1 is 0, x2 is 5. And what is the value here and here? How will you find out? You just see the intersecting point. If I have to use this one, x2 is equal to 5, and use this in this equation and try to get x1 value. So if you substitute here, you will get 0, 5, and here you will get 2.5. Yeah, you will get 2.5, comma 5, and here you will get 6, 3.25, and one more is here itself 6, here 3. So it is like this. So this is 6.25. Here it is 6, 3. Then here it is again as usual 0, it is not 4 because this one is 3, 0, 3. So find out the values for this. So this becomes, for this 0, 5, z value equal to 25. Then 2.5, 5. 2.5, 5, z value equal to 32.5. 6, 3.25. 6, 3.25, you will get z is equal to 34.25. If you do it in the graph sheet, you can find here one point here, then down, again it continues like this. Then 6, 3, z value equal to 33. 0, 3, z value equal to 15. So which gives us maximum optimal solution, which is within that range, 34.25. Now we'll solve this equation also. So here x1 is equal to 8. x1 is equal to 8 is here. x1 is less than or equal to 8. x2 is less than or equal to 5. x2 is less than or equal to, so the arrow will be like this. This arrow will be within this. This arrow will be within this. x2 is greater than or equal to 3. x2 is greater than or equal to 3. And x1 again, x1 is greater than or equal to 7. x1 should be greater than or equal to 7. Only the point here. You will get only this point. Why? x2 is less than or equal to 5. Yes. And x2 is less than or equal to 3. So since it resides within this, it should be within less than or equal to this. And x2 should be greater than or equal to 3. So you will, x2 is greater than or equal to 7. So this one, x1 should be less than or equal to 8. So you will get only one intersecting point here. So this value will be, this is 7, this is 3. So 7, 3, z value we will get 36. So if you compare it with our main, the value of z, so this is beyond that. So this leads to infeasible solution. Infeasible solution. So now how can I write here? If x1 is less than or equal to 6, I will get all these value. Maximum among this is z is equal to 34.25, x1 is equal to 6, x2 is equal to 3.25. If I consider this leads to infeasible solution. Now, can I stop here? No. 34.25. Still, if I continue in this, I may get more better integer as well as the optimal solution. So, since this is not in decimal, I will consider x2. This value lies between 3 and 4. So, x2 is less than or equal to 3, x2 is greater than or equal to 4. Include these two constraints in this and will still proceed. Consider these constraints. So, here x0 6.25 and this one. So, you have to join like this. Then x1 is equal to 8. So, x1 is equal to less than or equal to 8. So, feasible region is within this. x2 is less than or equal to 5. x2 is less than or equal to 5. So, x2, this is 2, 4, 5. So, x2 will be within this region. x2 is less than or equal to 5. x2 is greater than or equal to 3. So, again here x2 should be greater than or equal to 5. Again, my feasible region is within this. Again, x1 is less than or equal to 6. Again, x1 is less than or equal to 6. So, again it says that it should be within this. As of now, I have this much. But what happens here? x2 is again less than or equal to 3. This x2 is greater than or equal to 3, less than or equal to 3. So, I will be making this as x2 is equal to, it should be equal to 3. If I have to consider x2 is equal to 3, then I will get this solution. Because it should be within this, it should be within this, it should be within this. So, I will get this point. So, somehow it will pass like this. So, you will get this point. This value of this will be 6, 3. And its corresponding z value will be 33. Okay. Consider this. x1 is less than or equal to 8. x1 is less than or equal to 8. So, your feasible region is within this, within this. x2 is less than or equal to 5. So, again x2 is less than or equal to 5. So, feasible region is within this. x2 is greater than or equal to 3. Again, your feasible region is within this. So, x2 is greater than or equal to 3. Then, x1 is less than or equal to 6. Again, x1 should be less than or equal to 6. Again, the feasible region should be here. x2 is greater than or equal to 4. Again, it says x2 should be greater than or equal to 4. Greater than 4 and it should be within this. So, I will get only I will get this point as well as this point. Yeah, only these 2 points I will get. What is the value here? The value of this equation will be just 2.5, 5 and value of this will be 4.5. Somewhere here it comes actually 4.5, 4. So, z value will be for 2.5, 5, z value we will get 32.5 and 4.5, 4, z value will be 33.5. Now, consider. consider again. If I consider x2 is less than or equal to 3, what are my points? My points are z is equal to 33, x1 is equal to 6, x2 is equal to 3. If I consider this, maximum among this is this, so z is equal to 33.5 and the x1 is equal to 4.5, x2 is equal to 4. So here no need to further continue in the iteration, because if you compare to here, your objective function is decreasing. So we won't be considering this. Further we will not proceed towards this path because objective functions are decreasing in this direction. So what are all the values, optimal values for this function? Now the values are, see, this is integer, so you can consider this, and this is integer, so you can consider this. Among z is equal to 34 and the integer z is equal to 33, which is actually maximum, which gives you maximum optimal solution, this. So this will be our final answer. x1 is equal to 8, x2 is equal to 2, z is equal to 34. This is also solution, but compared to this, this gives you maximum the objective function value z. So x1 is equal to 8, x2 is equal to 2, z is equal to 34. Thank you.
Reva University, one association for many great careers.